video 1.3. This video is to get you ready to count significant figures. So all we're doing with this one is figuring out how to count significant figures. And in the next video, you're going to learn how to do math with the significant figures. So first off, a significant figure, you're pretty much counting how many numbers are in a number. And this is going to be important when we do the math part because there are certain rules that you have to obey by. So, determining the number of sig figs. So determining how many numbers are in a number. Now, count all numbers except the placeholders. So this is the main thing you've got to understand. All numbers are significant. All non-zero numbers are significant. So 1 through 9 are all significant. The tricky part is when you get these pesky little zeros. So you have to figure out if these zeros are significant or if they are placeholders. Placeholders have to be there to make that number what it is, but they're not significant. Okay? So you have two types of zeros, or three types of zeros. You have leading zeros, trailing zeros, and then you have your significant figure zeros. So you're going to count all numbers except the placeholders. So you do not count leading zeros. Leading zeros are the zeros in front of the actual number. So it's just like reading. You don't count anything until you hit a non-zero number. So in 0.0025, there's only 2 sig figs. These zeros are leading, so you do not count them. 2 and 5 makes 2 sig figs. So the key thing is you don't count anything until you hit the non-zero number. They have to be there. Okay, they're still important because they're placeholders. They're there to put that 2 in that third spot there. And that's it. That's their job. That's the only thing. Okay? Then you have trailing zeros without a decimal. Okay? So you never count leading zeros and you never count trailing zeros without a decimal. So, 2,500. The 2 and the 5 are significant. The zeros are not. They are simply there to put this 5 in the hundred spot, and that is it. They are not significant. Now, I can simply change this number to be 2500 decimal, and then that would change the number of sig figs. Okay? So, for instance, I could change this to 2500 decimal, and that makes that 1, 2, 3, 4 sig figs. Okay, so here again, and we're going to go through some examples as well, some more. So leading zeros never count. So I don't care if you have 50 million zeros. You do not count anything until you hit that non-zero number. So do not count 1 sig fig. Now, if you have a number greater than 1, okay, the only time you're going to count the zeros in the back is if there's a decimal. So 100, no decimal, 1 sig fig. Let's say 100.0. There is a decimal. So this is the key thing here. If there's a decimal, you count the zeros in the back. So we have 1, 2, 3, 4 zeros, or 4 significant figures. Now the trick comes in when you have something like this. 0.010. How many significant figures do you have? Okay, you don't count anything until you hit a non-zero number, so you don't count those. Then you hit a non-zero number here, so that's obviously 1. And then the question is, do we count the 0 in the back? We only count zeros in the back if there is a decimal. Since there is, 2 sig figs. Okay. Now, as we go through the next few examples, we're also going to go over scientific notation. So if you have trouble with scientific notation and you still don't understand it after this video, you need to make sure that you get me at some point and make sure you get it. Okay? So scientific notation, all you're doing is you're moving the decimal, so there's only one number in front. You are only allowed one number in front of the decimal. Okay? And then your times 10 to the whatever is how many times you had to move that decimal to that point. It's going to be positive if your number is greater than 1. It's going to be a negative exponent if your number is less than 1. Okay? So, 1.15. To put that in scientific notation. We move the decimal so there's only one number in front. In this case, we don't have to move the decimal. So in scientific notation, it's simply going to be 1.15 times 10 to the 0 if we were to put it in scientific notation. Sig figs. This one's easy because there's no zeros. So 1, 2, 3. 3 sig figs. Okay, next one. 101.5. Put in scientific notation. We need to move the decimal 2 times to the left. So the exponent is going to be times 10 to the positive 2 because this number is greater than 1. So for scientific notation, you get 1.015 times 10 to the second. Now, significant figures. The zeros in between, they always count. It's the only ones in the front and the back that you have to worry about. So for number of sig figs, it's going to be 1, 2, 3, 4. 4 sig figs. Okay, so let's try the next one. First, we put it in scientific notation. So we're going to move 1, 2 times to the left again. So it's going to be 1.0150 times 10 to the second. Count the number of sig figs. Look back at this original number here. There's no zeros in front, so we don't need to worry about that. We count all of that, but we have a 0 in the back. We have a 0 in the back. We only count them in the back if there is a decimal. Zeros in the back, there is a decimal, so we do count it. So that means we're going to have 5. 1, 2, 3, 4, 5. Okay. Next, 0.015. Put in scientific notation. So we're going to move the decimal all the way to behind the 1. So we're going to go 1, 2 times to the right. Now this time our number is less than 1 and we're moving the decimal to the right, so that makes it 1.5 times 10 to the negative second. Sig figs. You do not count anything, just like reading, going from left to right. You do not count anything until you hit that non-zero number. So when we get to that 1, we start counting. So 1, 2, 2 sig figs. Okay, next. 0.00150. Scientific notation. We're going to go 1, 2, 3 times to the right. So it's going to be 1.50 times 10 to the negative 3. Now sig figs. Don't count anything until you hit that non-zero number. So you don't count those zeros. You can cross them out, do whatever you need to. Then you get to the 1 and the 5. They're significant, so that makes 2. Then you have this little guy in the back. It's in the back, but we have a decimal. Back and decimal equals significant. So that gives us 3. Okay, 150. Put in scientific notation. The decimal's in the back of the number if it's not shown, so we're going to move it 1, 2 times to the left. So that makes it 1.5 times 10 to the second. Significant figures. No leading, so we're good. The 1 and the 5 count. We have a 0 in the back, but what are we missing? A decimal. In the back, no decimal means no count. No decimal, no count. So that gives us 1, 2. That is a placeholder 0. It is only there to make it 150 instead of 15. Now, the 200 here. In scientific notation, we're going to move it 1, 2 times to the left, so 2.00 times 10 to the second. Now, in your notes, you should see this line above the 200. That line is significant. Okay, in your math class before, it just tells you that a number is repeating in a decimal. If it's above a 0, which you don't really see in a math class typically because you don't put repeating zeros, a line over a 0 means it is significant. I am telling you that both of those zeros are significant, which means our answer for number of sig figs is 3. Okay, 3,000 with the decimal at the end. Scientific notation. So we're going to go 1, 2, 3 times to the left. So that makes it 3.000 times 10 to the 3. And then to get sig figs, no leading. We do have trailing in the back, but we also have a decimal. Back plus decimal means significant. So that gives us 1, 2, 3, 4. Now, the next part of this video is about rounding. I didn't used to have this slide in here. I sort of added it this past year just because I've come to a conclusion that students don't quite understand how to round. So when you round, you only round the last number you are keeping. You do not multiple round. Okay? So if you have a 4 or below, then your number stays the same. If you have 5 or more, you round up. You must add zeros if needed as placeholders. So this is what you're going to have to do. You're going to get these answers and you're going to have to put them in the correct number of sig figs. So for instance, 345.67, I want it rounded to only one sig fig. So you're going to keep the first number and then you're going to add placeholders until you get to that decimal spot. So 345.67 with one sig fig is simply 300. Most common mistake is to tell me 3. You cannot move the numbers from the place that they're in. So if this 3 is in the hundreds, when you give me the answer, it needs to stay in the hundreds. Now what I want you to do is pause for a second and answer these two questions. So you're going to round 456.70 to 2 sig figs, and then round this number to only 1 sig fig. Okay, so 456.70. When we're saying 2 sig figs, it means you're going to keep the first 2 sig figs that you have. Then you always look at the number that's after it to see if it's going to round that 5 up or not. So is 6 going to round the 5? Yes, because 5 or more you round up. So the 4 stays the same, and the 6 is going to round the 5 up to a 6. Most common wrong answer is 46. Okay? Your original number is 456.70. That means this 4 has to stay in the hundreds. So to keep it there, we have to add one placeholder. So your answer is 460. Now, when you have a number less than 1 and you're trying to do sig figs, you're going to put all of your placeholders in, and then you keep however many sig figs you need. So we're going to keep 0.0000, so the 4 zeros, and then we're only going to keep 1 sig fig after that. So we're going to keep the 3. Now, question is, you only look at that number right after it. I do not care about this 9 and 2. We are done with that. So does this 4 do anything to that 3? No. So your answer for this one is that. We will be doing a lot more practice in class with this. So don't stress if you're kind of on the brisk of not really knowing what's happening or whatever. We will practice this.